Okay, a store manager records the number of customers at a store each week for several days. The data are approximately normally distributed with a mean of 1245 and a standard deviation of 35. The manager wants to predict future customer totals. Using the data above, what percentage of weeks will have between 1280 to 1350 customers? Okay, circle the word percentage. Anytime they start giving you standard deviation, mean, we know that we are going to use this normally distributive curve. So please draw it. You always, always, always have to start with that. I had students on the last test, who, bless you, who made mistakes by just assuming they could always use normal CDF. Can't just always use normal CDF. So I'm going to start by lining 0 up with 1245. Then I have 1, 2, 3 above the mean, 1, 2, 3 below the mean. Bless you. Okay, take the standard deviation, which is 35, and now we're going to add 35 to 1245 as I go up, and we're going to subtract 35 as I go down. Excuse me. Please complete that right now. Go. 30 seconds. Bless you.
Thank you.
Correct me if I'm wrong here, if I am adding too quickly and make a mistake. So this is what I have. Feel free to write those down. And it says, I want to know what the percentage. Well, let's write down the percentages. Here is the middle. Remember, this is symmetrical, and underneath the curve adds up to 100. This is 34, 13.5, 2.35, and 0.15%. And it's the same thing on the right-hand side. So we want to know what percentage is between 1280 and between 1315. Well, first of all, because those two numbers lie directly on those columns, it means I do not use normal CDF. Instead, I just have to know what percentage is in this column. Again, here's 34. That makes this 13.5%. Let's go down to number 2. Number 2, I use the exact same, literally the exact same question or word problem, but I just put in different data. So let's make a normal curve. And this time we have a mean of 1233. Right. Great question, Jenna. So I just wrote down the answer. But as we can see, there's no percentage here. So if they did give you something like this, if they gave you just a box, I'd write 13.5% done, right? But if they gave you something like this and we had to put in the answer and we don't see any percentage symbol, then you would move the decimal 2 places to the right and we'd type in, or we'd write in 0.135. No, because this is the actual, it says round to the nearest 1/10 of a percent. So right here, we don't actually have to round it because there's no number behind it. It's a 0. Great questions. Down here, I've already filled in the numbers below. Now I need to identify where 1220 lies. So 1220 is somewhere in here, and 1300 is somewhere here. So in both cases, they do not lie in the lines. That's when you know you have to use the normal CDF. So grab your calculator. And I want to use one that looks just like yours. Do second vars. Go to normal CDF. And how do you plug in the four numbers? It's the smaller of the two numbers, 1220, comma, the larger of the two numbers, 1300, comma, then it is going to be the average or mean, and followed lastly by the standard deviation. And it says to take this and round your answer to the nearest tenth of a percent. So if I move it 2 places to the right, it'd be 60.2%. So if we just had a box, I would write this in it. If I had to turn it back into a decimal, it would be 0.602. Go down below, please. And before we do this, let's change kind of how this question looks. Let's first decide there's 3 types here. Please write down survey, experiment, and observational study. We have 3 types. And we're going to read each of the 4 short prompts and decide what would be the best way to answer that question. Would it be in terms of a survey? Would it be in terms of an experiment? Or in terms of an observational study? The first one says, how many teachers at a high school have completed a marathon? So how do we find out the answer? We survey. What is the effect on an individual's weight loss when a soda is eliminated from their diet? Experiment. What is the average salary of teachers in Arizona? Survey. We're going to ask them. What is the most popular major selected by freshmen at ASU? Survey. We're going to ask them. So you may be wondering, like, what would be an example of an observational study? So observational studies sometimes can be a little skewed because they're based on people observing others, and based on whoever they're observing, they're based on their emotions. Like, let's use my 9-month-old. So let's take and put some type of a toy in front of her, okay? So some type of a toy. Maybe it's all little animals. And next Monday, exactly at the same time, at 9 o'clock when she's wide awake, 9 o'clock, I put little tiny toy animals in front of her, and I watch her for the first hour. And then I take them away. And then on Tuesday, instead of putting animals, I put blocks in front of her and allow her to play with blocks for an hour. And I watch her. And on both times, I'm watching what she's doing, and I'm observing her emotions. And it's going to be how she expresses her emotions as how I determine which type of toy she prefers. Okay? What's the problem with observational studies? Would you agree in adults, not all adults show emotions the same way? So sometimes adults may be satisfied with something, but some adults, whether they're happy or they're mad, they have the same look no matter what, right? So sometimes it's hard to get a true answer to a question using an observational study. Flip your paper to the back. Yeah.
So, for the example that you gave of the observation, when you were inputting the toys, like you were giving toys, wouldn't that be an experiment then? Because you were giving toys rather than just observing without doing anything.
So you're saying because I'm doing 2 different things against each other, right? But how I'm determining the answer is just on what I'm observing.
Oh, okay.
Does that help you?
Yes.
Okay. All right. So there's no data other than my observations.
Yeah.
Okay. So number 4. Before we even get into number 4, I want you to pretend for a second that you're a doctor. And when you prescribe medicine, it's important that when you choose a particular medication that you are confident in the results, correct? Okay, so that's what this kind of is based upon. So this experiment study is based on a new medication that compares the recovery time in days of 2 treatment groups of randomly assigned surgical patients. Which statement below best supports the conclusion that group 1's treatment is preferred for a population of surgical patients? So when a doctor gives a medication, they like to say things like, we expect to see you better within a week, right? So if Jaime's not feeling better in 2.5 weeks, that medication did not work for Jaime, correct? So they want there to be a very small window. When they say a week, they're thinking hey, yeah, you should be feeling better within 5 to 8 days, 5 to 9 days. So whatever number they give you and what that medication says, it should be a very small range above and below those number of days. So group 1, there were 78 patients that had surgery, and in group 2, there were 75 patients that had the same surgery. The average number of days to recover with group 1 using that particular medication was 27, and the average number of days for group 2 was 24. Now look at the standard deviations. They're quite different. And I want you to read right now A through D. I'm going to give you 1 minute, and then refer back to these standard deviations to see if you can decide which one you think is the correct answer. Ready? Go. How many of you see the word standard deviation? You're not exactly sure what that means. Hands up high. Standard deviation means how spread out are the data points from the average. So the average is 27. This means that the amount of recovery days for these 78 patients is really close to 27. Okay, so they're not spread out too far from the average. But what about this one? Even though it's a smaller recovery time on average, do you see how more spread out the days are? So when a doctor would give this medication, it's really variable how long it's going to take. This tells you that it's not consistently giving the same results, and doctors want the same consistent results. So why do we choose group 1? And the reason is because the standard deviation of this group is much less and does a better job of limiting long-term recovery times. We know, based on how the data is spread out from the average, that most people are going to take right around 27 days to recover.
Wait, then why wouldn't it be C then?
Did I read it wrong? Let's see here. Because the standard deviation for group 1 is much less than for group 2. Okay, so we got the part. More patients in group 1 have shorter recovery times than group 2. That's not necessarily true. Do you see how this has a shorter recovery time? But it's variable. So although this is the average for this group of 75 patients, because the standard deviation is so high, that means the data points of how long it takes them to recover are more spread out. Where consistently, if we put these on a timeline and we said, plot the number of days it took for you to cover, for the most part, they're all going to be clumped around 27. Does that help you, Stephen?
Yes.
Okay. So let's come down here. And this describes a convenient sample. Turn to your partner review. What is a convenient sample? Jaime, can I call on you? Let's go with it. Okay, ready? So Jaime is volunteering. It's okay if he doesn't know these. We're going to go over these, and you guys are going to help me remember. So convenience, what is it, Jaime? As simplified as possible.
As simple?
Yep. How would you describe it?
When a sample is just convenient.
Sample is taken convenient. It's the lazy way. Hey, let's ask the first 10 people that walk by me. Okay? What is self-selected?
You select them yourself.
They volunteer to be part of one. And that could be this, by the way. I haven't read through this before. So this could be self-selected. Let's go over the other ones. What is simple random sample? Draw out a hat, right? We randomly select from a group. Okay? What is systematic?
Choosing every 5th person.
We have a rule of how we're going to do it. So we have a starting point. We say every 10 minutes we're going to go after the 5th person in line. All right? There's no bias to that, to those last two. What about stratified versus cluster? Turn to your partner. What is the difference between those?
Stratified? No. Cluster, you choose a group, but then everyone's stratified is. Yeah. Stratified is you do the random simple one inside each group.
So with stratified, similar to cluster, you have a common characteristic that divides the large group into smaller subgroups. Yes, with cluster, we often do it by a location, like a zip code, right? Or county or neighborhood. But with stratified, so you have similar groups based on whatever your characteristic is. In this class, let's pretend we had a more variation of students. We have freshmen in here, we have sophomores, juniors, and seniors. And so I'd say in each one of the 4 quarters, please, freshmen, go to this quarter, sophomores, go to this quarter, and so on. So I'd have 4 separate groups. And then in stratified, I would choose a number, and let's say it's 3, and I'd randomly go to each group, and I would randomly choose 3 from each of the 4 separate groups. Okay? But how does cluster work? Cluster is, yes, it's based on common groups like stratified, but it is often chosen based on location, how we group things. And then we randomly choose groups, and once your group is chosen, everyone in that group is asked the question or surveyed. If your group isn't chosen, nobody in your group is selected. Okay? Keep that in mind as a little review. So at the beginning of the second term, Stugo wants to create a committee of 25 students who are not currently in student government to help advise the class on future decisions related to advisory period for next year. The committee should represent the views of the entire student population. Circle that, please. So if you're going to represent the views of the entire population, how do you do that? Your survey must be non-biased. It must be things like simple random, or stratified, or systematic, or clustered. So how does Studigo do this? The first 25 students to volunteer are selected. In fact, I was wrong at the beginning. The first 25 students to volunteer. What type of a survey is this? Self-selected. Those are not good ways to get feedback that represents the entire population. So is this a good method for selecting students? No, it's not. The reason why is the first 25 students are not guaranteed to be a good representation of the entire student body. Before I do number 6, I want to, did I choose the wrong one? Did I say the right thing? Okay, hold on. No, it's not good because the first 25 do not represent the ideas, may not represent, how about this? How about A? I said it and circled wrong. Thank you for correcting me. Okay, so before we do number 6, let's review the questions we used to do about margin of error. Okay, you're conducting a survey, and Stephen is just really busy. We see Stephen there, he's all these classes, and Stephen's supposed to do a survey, and he's supposed to help out with the newspaper, and he goes ahead and he surveys 16 people. Figure out his margin of error right now. Ready, go. 16 people surveyed. Frank, I'm going to ask you shortly what your answer is. Please round your answer to the nearest percentage. Who needs a little refresher? How do we find margin of error? General formula.
1 over the square root.
1 over the square root.
Plus or minus in front. So do you end up with 0.25?
Yes.
0.25? So what does that turn into? It is
Plus or minus.
plus or minus 25%. That's a pretty big margin of error. That's a pretty big margin of error. What if Logan was given the same assignment and he surveyed 330 students? Figure out his margin of error. 330, please. Okay, if we round to the nearest 10th of a percent, what would that be?
Plus or minus 5.5%.
Plus or minus 5.5%, okay? And let's stay with Logan's here for a second. So we know Logan's margin of error is 5.5%. And let's say Logan did some type of a question with the newspaper, and whatever the question was, the answer turned out to be, pay attention, the answer turned out to be that 52% of people said yes to the question that Logan asked. So if yes was the answer to 52%, what is the interval that we can assume the true population or the true answer would occur in? If we know this is the margin of error, and Logan comes back and says the results are that 52% say yes to my question, what is the interval where we assume the true answer occurs? Well, to do that, take 5.2 and add 5.5 and subtract 5.5 from 5.2. We can assume that the true answer lies between 46.5% to 57.5%, okay? Based on our margin of error and the answer we have. Now, let's jump over, that was a quick review, let's jump over to this one. I'm going to have one person from each group, please read out loud, go ahead. gives us a specific formula. If this happened to be the formula they would provide it for you, you would not have to memorize this. This is our general formula we use, but this is a more specific one, okay? So what should you use if they're talking about margin of error and they provide a formula? Use the formula they give you. But in both cases, N represents the number of people that were surveyed. In previous classes, students jumped and go, okay, 5 people were surveyed. That is not true. It says 5 random students were selected from each of the 4 classes, which gives you, so 20 is your N from this problem, and they give you an answer of 0.75 for S. Please get an answer and round it to the nearest thousandths. Go ahead. Check your answer with mine. Okay, we're not all getting that. Maybe I made a mistake. Anybody else get this answer? Okay, let's try it together. Take 0.75 divided by the square root of 20. Get an answer, and then take it times the 1.96 out front. Round it to the nearest thousandths, which would be approximately 0.329. Flip to the next page. Put that on my desk. Which one on my desk? Think now's a good time to pull out a phone? Hopefully you can find me before I leave today. Okay, I need my creative thinkers out. You ready? Number 7. The junior class, 2 junior classmen, Braxton and Edwin, are both running for next year's senior class president. And Karen conducts a survey to determine which classmate is most likely to win. Now, in order to conduct the survey, she decides to survey all the students only in my classes throughout the day. And then she finds that 71% of the students in my classes say they're going to select Braxton. Well, I have a question for you. Does my classes represent the entire junior class? Is it a good representation? Not a good representation, right? What if they would have, what instead if Karen would have said, okay, junior class, so I'm going to go to the junior English classes, and I'm going to choose two random classes from each junior English teacher, and I'm going to survey all the students in that class. Would that be a better representation? Right? Because it'd be randomly selected, better job. All right, so keep in mind, this is not a great way of doing this. Okay, select all the conclusions that can be drawn from Karen's results. Can we assume that Braxton is going to win? No, cannot do that. Now, what if only the students in my classes were going to vote and nobody else was going to vote? Can we assume that Braxton wins then? Yeah, but that's not happening. Edwin has a 29% chance of winning. Not true, because we don't assume that this is a good representation of the entire population. 71% of the junior class will vote for Braxton. No, 71% of the kids in my classes will vote, but since it was not a good, simple, random sample, it was a biased sample, we can't assume that that is an accurate representation of how the entire junior class feels. Karen's survey methodology is biased. That is true. And most of the students in Karen's classes will vote for Braxton. That is true too. Okay, let's give an example here, and let's cross out the word Braxton, and let's just write the word Stephen. Okay? So, let's change it up and pretend Stephen is currently a junior. Stephen is mostly in pre-AP or in honors classes, and so it is true that people that have those classes know Stephen. But it's very true probably that people that are mainstream may not know Stephen, correct? And so if you only surveyed my classes, they'd be like, oh yeah, I know Stephen. Stephen's in my class in 3rd hour in chemistry, or Stephen's in my pre-AP English class. And so they're much more likely to know Stephen, and Edwin is not in honors classes, and so that's why he has more votes, okay? Versus if they had had a better job of sampling the entire population, we could have gone with those results to kind of predict who we think would win. Okay, number 8 is the last one from this packet. And this goes back to some common sense, but I need to take out one word. take out the word attend, please. Take out the word attend. Okay. So, Mr. Camp is considering adding an hour-long ACT prep opportunity that would be administered by Miss Geary, the one and only ACT queen. He surveys 500 random students on campus. So is this a good job of surveying? They're randomly selected. Good job of surveying. Good. So we can trust the data. And he wants to find out whether they are currently attending ACT prep after school with Miss Geary. Then he asks the second questions and asks whether they would attend if ACT prep were also offered before the beginning of the day. So his first question is, do you currently attend ACT? And 7% said, yep, I currently attend. And then he asked the second question to those same students, and he said, would you continue attending? Or if you're not currently attending, if I offered a morning session, would you attend? And 9% then answered yes to, I am currently attending, or I would begin attending if a morning session was answered. So, yes, the same students. We know 7% of the 500 said yes. And we know this is a good representation of the entire population. So we can assume this percentage would also be pretty accurate of the entire population. So please take 7% of 3184. Please take 7% of 3184. And we can assume right now, oh, Miss Geary would be in heaven right now. We can assume that right now, 223 students say that they attend after school ACT sessions with Miss Geary, according to this, okay? What's the difference in the second question? What's the difference now in the percentage that say, hey, I'm going to start attending if there's morning out, what percentage say I'm going to start attending if a morning session was offered? Okay. First question is, do you currently attend? Yes, 7% say yes. This question is, do you currently attend, or would you start attending if morning was offered? And this 9% said yes. So 2% currently don't attend, but said they would start attending. Figure out what 2% of the entire population is. Somebody share it with me? 64. So if they offer this session, how many students can we assume Miss Geary would be seeing per day? 287. Mr. Camp says, you know what, I can't make this before session class happen. I can't find a reason to justify paying Miss Geary for this before school session unless I know that 50 students say, yes, I'm going to start a 10 morning session and currently I don't attend. So is it true that this survey says that we have at least 50 students who say they are going to start attending? So the survey says yes, because there would be approximately 64 more students attending ACT prep. Okay. We are going to do, flip to the back here. If you have not logged on, I have 5 problems, and then you are going to have to watch a really quick video. So if you have not done so, log into the computer. If you have not done so, we're going to get through these together. Give me 1 second. Sorry, guys. Okay. Does everybody know which page we're on right now? Yes? You were asked to attempt this?
Oh, yeah.
We're okay?